Hello fellas, in the last video we did a couple examples but did more review of inverse trig. This video is going to be solely dedicated to doing some examples and make sure that you're understanding the concepts behind inverse trig. So let's get started. Um, Here's a little different problem. I want to use an inverse trig function to write theta in terms of x. Okay, and so I have a right triangle here. Here's my right angle right there. And so I should be thinking about right here that cosine of theta is equal to 4 over x. And then if I wanted to solve this for theta, obviously I would take the arc cosine of both sides. And remember, if I do that, if I go arc cosine of the cosine of theta, I'm simply going to get theta because these two functions are inverses of each other. So I'm going to do that at both sides, and what I'm going to get is that theta is equal to the arc cosine of 4 over x. Okay, just taking the inverse of the cosine function there. In this particular problem, I have different sides here, and you guys should be thinking right off the bat that I want to use arctangent, okay, or the tangent function. So I would write this as tangent of theta is equal to x plus 1 over 10, opposite over adjacent. And again, I would just take the inverse of the tan, which is arctan. So theta would be equal to arctan of x plus 1 over 10. Okay. Here I should be thinking about sine. So I should have sine of theta is x plus 2 opposite over hypotenuse. So that theta here is equal to arc sine of x plus 1 over 2. Okay. Hopefully that makes sense. Again, just solving an equation. It's almost like if I had 3x plus 5, 3x equals 5. I'm multiplying by 5, I do the inverse, I divide by 3, I divide by 3, and I get x equals to 5 over 3. Same idea here. I have the sine of theta. To undo the sine, I do the arc sine. And then I'm just left with theta right there. Okay? Find the exact value of each expression. So now I have the arc cosine of 7 pi over 2. First thing I want to do is evaluate cosine of 7 pi over 2. Again, you guys should know what that is. That's actually equal to 0. So I have the arc cosine of 0, and then we should know arc cosine of 0 is equal to pi over 2. Okay, remember that if I set this equal to y, that means that the cosine of y is equal to 0, and I have to be on 0 to pi. That's my range. And I know that on that interval, that cosine of pi over 2 is equal to 0. Like that. Okay? Tan of arc sine of root 2 over 2. So now I need to know arc sine of root 2 over 2. We should know that. We should know that that is equal to pi over 4. Okay? Which means that the sine of pi over 4, this statement right here, means sine pi over 4 is going to be equal to root 2 over 2, which we know it does. Tangent of pi over 4, we should know again from our unit circle is equal to 1. Arc cosine of the sine of 2 pi over 3. So we need to know what sine of 2 pi over 3 is. Hopefully you guys know that. We're in the second quadrant. Sine is still positive in the second quadrant. And so what that gives us is 1/2, root 3 over 2, sorry. So I have arc cosine of root 3 over 2. This value here is going to be in the first quadrant, all right? And we should know that that is pi over 6, all right? Do another one. Arctan of root 3, we've done this one earlier. Remember, if we're confused, this, we would rewrite it as tan of y is equal to root 3. We're in the first quadrant. Remember, we got to go from negative pi over 2 to pi over 2. Okay. Sorry. And in this situation, when is tangent equal to root 3? Remember that tangent is equal to sine over cosine. Okay, and we're going to get this as pi over 3. This is going to be pi over 3, because this will be root 3 over 2 over 1/2, which is root 3. So this should be sine of pi over 3, cotangent of pi over 3. Cotangent now is cosine over sine. So I'm going to have cosine pi over 3 over sine pi over 3. This is equal to a half over root 3 over 2. So that's going to be equal to, I need to simplify that, and I'm going to get root 3 over 3. Okay? You guys should be able to simplify it from right here. Alright? Let's do some more. Arc sine of 4 over 5. Now this isn't one that we necessarily know, but what I can do is draw a triangle here. And so let's do that. Let's draw a triangle. Arc sine, this means that the sine, we'll say the arc sine, what we're going to do here is we're going to say arc sine of 4 over 5 is equal to theta. That means that the sine of theta is equal to 4 over 5. This is my opposite side. This is my hypotenuse. So I can draw a triangle here. And once I know the triangle, I can use the Pythagorean theorem to find the other side, which would be 3. Okay. Once I look at that, I know what the secant function is. Secant function is, let me just go through some of this for you. We're in the first quadrant because we're positive. I know that secant is 1 over cosine. So the cosine of theta here is going to be equal to 3 over 5, and that we know that secant is 1 over cosine. Okay? So we should get 5 over 3. Alright, hopefully that makes sense to you. Let's do another one here. Our arc cosine of negative 5 over 13. Again, don't know that one off the top of my head, so I got to draw a triangle. Alright, let's draw a triangle. So that means if we say arc cosine of, let's say, 5 over 13 is equal to theta, then theta, cosine of theta is equal to 5 over 13. Now I can draw a triangle. I'm going to deal with the negative sign in a second, but I got to have my adjacent side over my hypotenuse there, and so I can solve for that remaining side using the Pythagorean theorem. Okay, so it says cosine of theta is equal to 5 over 13, which we have up there, and so theta is going to be arc cosine of that. But we also need to know we're in the second quadrant, and we're in the second quadrant because we're looking at negative right here. Okay, and we know that cosine is negative in the second quadrant. Okay, so we just have to be mindful that our angle is in the second quadrant. So tangent is also negative in the second quadrant. So let's continue on here. So if tan of arc cosine of negative 5 over 13 equals tangent of theta, so let's find tangent of theta, which is going to be 12 over 5. But I do make it negative because we're in the second quadrant. Okay? Remember, arc cosine is going to give me a value between 0 and pi. And cosine is negative in the second quadrant, and that's why we have this stipulation right there. Okay? Here's some more practice problems. Okay? Practicing along the same lines as what we just did and using the inverse property. So, again, if you have any questions, make sure that you're emailing me. I'm going to do another video on some more practice, on some more examples, no new material, just to make sure you guys are getting the hang of it. All right? Have a good day, fellas.